Okay, lesson 6-7. Quick recap for the video's sake. Okay, area between two curves. Traditionally, we have done upper minus lower, and when we've done that, we're working with curves in terms of x, where it's y equals, it's explicitly solved y equal in terms of x, and so we're working with x's, upper minus lower. Okay, so on there I wrote the integral of f of x minus g of x dx, upper curve minus lower curve. Okay, that rectangle in there is representing the upper minus lower. Okay, now look at the second picture. How do you do upper minus lower here? Yeah. So the difference here is, notice it says we're going to use the same concept for the areas of the pictures like the following, only we have to use the equation in terms of y instead of x. So right here, as you look at these two functions, we don't have an upper minus lower because there's never one curve that is above the other because this one is a sideways parabola. I mean, there's a small section here where you could say g is above f, but over here, it's all just f. And so when we work in terms of y, instead of saying upper minus lower, we're still going to say larger minus smaller, except we're going to use, I'm going to say right minus left, if that works for you. In terms of the integral, my right is f of y. So f of y minus g of y, and then dy. And this is the idea of right minus left. Okay, so that'll be the big difference today. I'll notice the side comment down there. We also have to think about our a and b values. Okay, normally when we do upper minus lower, our a and b values, our boundary values are the x values. Well, when we do right minus left and we work in terms of y, our a and b values need to be y values. Okay, so it's going to be based on the y-axis instead of x-axis. Or, notice it says, just pretend you're looking at the picture sideways.
Would the a to b values be opposite? Like, if you flip it just dead sideways, wouldn't you be going, like if you went from left to right like we generally do, wouldn't you be going from the upper to the lower? And wouldn't that be wrong?
I'm not 100% understanding what you're asking. I mean,
so like on like this curve here, we'd say that this was A and this was B, right? If we're trying to,
because B is traditionally the bigger value. Yeah. Yes.
So if we flip it sideways, if we still say this is A and this is B, that'd be wrong, right? Because
yeah. We
have to like reflect it when you flip it.
We'd be looking more at from here over to here. No, wait. Now you've got me confused on this one. Either way, I guess, okay. Either way you look at it, you want your B value to be the bigger value. Okay, so when we say A to B, A is your smaller amount, B is your bigger amount. Okay, and so, yeah, when you look at those, sorry, I had to get my brain on right. When we look at those, I guess you do just have to reverse it if you try and look at it sideways. I don't know. We'll kind of clear it up when we look at these problems here in a moment, and that will help. Okay. Okay. So look at this first example, see what happens. Find the area of the region completely enclosed by the y-axis and the graph of x equals 1 minus y squared. Okay. So, first thing I'm going to suggest is that we Look at a picture. Find the area of the region completely enclosed by the y-axis. That's easy enough, yes. What is the equation for the y-axis? I know you have the visual of the y-axis. What's the equation for the y-axis? X equals 0. That's going to be helpful to know here in a moment. Okay? And then the graph of x equals 1 minus y squared. Well, it's already solved for x and in terms of y, yes? So that will work well when we are setting up our integral. The problem is, can you visualize that picture? Okay. And so my recommendation is, let's take this and solve this for y, because we need a picture to make this make sense. Okay, so that's the only problem here is that sometimes you have to solve it one way or the other to make it work. So if I solve this, let's see, if I add y squared to the left, it's positive y squared. If I subtract x to the left, 1 minus x, you guys, I did a double switch there, you got that? And then how do I solve for y? Square root. In an equation setting, don't forget to say plus or minus. So this is y equals plus or minus the square root of 1 minus x. Okay. I will also say up here, if you notice up in the original problem, there's an x to the first and a y squared. Normally, if it's y equals and it's x squared, it's a vertical parabola. Instead of having x equals and y squared, this is going to be a horizontal parabola. Now, you can graph these on your calculator if you want. Let's see, what do we have here? So if I look at it in terms of a sideways parabola here, that is y squared equals 1 minus x. Sideways parabola, the x being negative means it's going to open, instead of opening to the right, it's going to open to the left. And that 1 means we're going to scoot, I should use the word scoot. We're going to translate 1 to the right. Sorry, it was Haley Stackelback that we always joked in Algebra 2 about scooting. Like that was the word she used.
That's the proper math.
And so it became a joke in her class that we talked about scooting. Okay, I should use the official word of translating though. So what you have is you have a parabola going through 1 that looks like this. Okay? Now, if it's a traditional parabola, and my vertex is over here at 1, we're going to have to know, where did these pieces cross? Yep. 1 and negative 1. And I don't know, did some of you try the calculator?
Yeah.
Did it work out okay on the calculator so that you can... Yeah, you do have to graph both of them. There's no way to do it otherwise. Helps if you put the negative in, Amy. Okay. Okay, so you have that parabola there. Now, specifically, what was it? The area enclosed by the y-axis, which y-axis is this, right? And the graph of x equals 1 minus y squared. What are we finding the area of? Yeah. This little thing right there. Okay. And officially, in terms of ordered pairs, crosses through at 0, 1, 0, negative 1. For reference sake, this top graph was my y equals square root of 1 minus x. This bottom graph was y equals negative square root of 1 minus x. Okay, you should try and figure out how this picture all goes together. Okay. I'm ready to find my area when you are. Okay. Notice my original equation was in terms of y, right? It was x equals 1 minus y squared. So we're going to be, since it's x equals 1 minus y squared, we're going to be using that 1 minus y squared. Instead of saying upper minus lower, it's right minus left. What's my right curve? Okay, x equals 1 minus y squared. So we're going to use the 1 minus y squared minus, what's my left curve? X equals 0, which is just 0 officially. dy. And what are my boundaries? Because we're in terms of, working in terms of y, we have to have y values. And where do these two graphs intersect? So where does your parabola intersect your y-axis? And that is at 1 and negative 1. And remember that 1 and negative 1 are y values. Everything is in terms of y. Now, this would be the equivalent of finding the area under a curve, right? The area under a curve where they don't give you another curve, it's just the area between the curve and the x-axis. This is the equivalent form, but in the y world. So the area between the curve and the y-axis. And I put the 0 in there for effect. Obviously, do you have to have the 0 in there? No, I put it in there for effect just to show right minus left. Okay, shall we do the math? What's the integral of 1? But not x. Y. Yes, I'm being nitpicky, aren't I? Integral, there's minus, integral of y squared. 1/3 y to the third. And then 0, we don't have to worry about. This is evaluated from negative 1 to 1. This is good practice without a calculator here. So we're going to first put in 1. So 1 minus 1/3. And then we're going to subtract. And now we're going to put in negative 1. Yes. I was stopping to think. So it's negative 1, it's minus 1/3 y cubed. So that'd become minus negative 1/3, so plus 1/3. Because if 1 minus 1/3 is 2/3, minus negative 1 plus 1/3 is negative 2/3. 2/3 minus negative 2/3 is going to be 4/3. Officially, I'm going to say 4/3 units squared. And we put numbers in. Forget the plus C. Okay. Example 2. Find the area completely bounded by the graphs of x equals 3 minus y squared and y equals x minus 1. Well, x equals 3 minus y squared. Are you kind of seeing similarities to last time? Okay. Sideways parabola again. Opening left again, this time shifted 3. However, could you solve it for y? If we solve it for y, it's y squared equals 3 minus x, and so y is plus or minus the square root of 3 minus x. What about y equals x minus 1? That's okay to graph, isn't it? What about when we go to put it into our setup? Needs to be x equals. And so if we make this x equals y plus 1. Okay, so you kind of have to work the medium. We need to know how to graph it, but we also need to know what goes in the equation. Okay, you guys know I want a picture. We need the visual. Okay, if you graph it on the calculator, you will see that the vertex of the parabola goes 3 right, correct? And if you think about a basic parabola, what's a parabola do? It goes over 1, up 1. And so you can think about it going, my parabola's not drawn great. You can think about those dots there. And then past that would be over 2. And then 4, which, so 1, 2, 3, 4. I didn't get this drawn at all right. Okay, next time we'll do the dots first. That looks horrible, sorry. What about y, what was it? Y equals x minus 1? I really messed this up. Gosh. Worst graph ever. Okay. Negative 1 y-intercept, right? Rise 1, run 1. Rise 1, run 1. Are those points helpful? Gosh. Oh my goodness. This makes me want to white out the whole graph and start over. This is bad. Sorry guys. Don't follow your leader on this one. It was bad, really bad. Okay. It says the area completely bounded by the graphs, yes? So do you see where you're going to be finding the area of? Okay. Whether you do this via calculator or via hand, you need those intersection points. Yeah. 2, 1, and negative 1, negative 2. Mine would be much easier to see if I'd drawn my dots and then did my parabola, but I didn't. I had a moment. I wasn't thinking. Okay, you guys ready to set up? Okay, so in order to find our area, the integral, what are we doing here? Okay, Daryl's suggesting from negative 2 to 1. Do you guys agree with negative 2 to 1? Because we have to use the y values, right? So negative 2 to 1. Okay. And then what about our functions? Okay, so what's the first equation I'm putting? Okay, the parabola. because that's the farthest right. So we're going to say 3 minus y squared, that quantity. Notice I'm using parentheses, yes. Minus, what's the other function? Y plus 1, because you have to use the x equal version. So we had to do the work on that one. Y plus 1. Got it? And these were y values again. Are we okay with that setup? Now, me personally on this one, before I integrate, would it be worthy of doing a little bit of cleanup? I think it would, just because you have a little less places to plug values in later. So if I do a little bit of cleanup, the integral from -2 to 1, 3 minus 1 becomes 2. We still have minus y squared, and it's going to be minus y dy. I'm not saying you have to do that, but I think it's just a little nicer cleaned up there. Okay, especially if you're doing this by hand, right? Which we're still practicing doing these by hand. So, okay, integral of 2y minus integral of y squared. 1/3 y cubed minus integral of y. 1/2 y squared. Evaluated from -2 to 1. Okay. First of all, we're going to put in our 1. So when we put in 1, 2 minus 1/3 minus 1/2. Well, that was easier. Then minus, I'm going to set up my other parenthesis. This time I'm putting in -2. So, -4 plus 8/3, that's what I was thinking. Minus 2. It's kind of up to you how you go through and do all of this from here. If you look at everything, everything has a common denominator of 6. Some of you may have bits and pieces you put together before others, but if I make it all 6, 12/6, minus 2/6, minus 3/6. That's going to be minus in my other parenthesis. Oh, I see. I glanced at my notes and it threw me off. I went ahead and put -4 and -2 together and said -6 and made that 6. Does that make sense? So -2 and -4, or you can put it together later, it doesn't matter. But -2 and -4 is -6. And as 6 is -36/6 plus 16/6. I don't know, however you guys want to do it. So 12/6 minus 2/6 minus 3/6 is going to be 7/6 minus -36/6 plus 16/6, -26. So did you guys get 27/6? (27/6) would be acceptable. It technically also reduces to be 9/2 if you catch it. Okay, I believe that's all we have. Okay. You are still much more likely to see the traditional upper minus lower work in terms of x. However, this is something that will occasionally pop up. Okay, so it's still a skill we need to work on. Needless to say, when I was assigning integral practice on AP Classroom yesterday, I skipped anything that was involving y like this because I knew it was supposed to be taught yesterday, but it wasn't. So I know AP Calculus is hard enough, and I'm afraid if I throw too much random stuff at you that you really have no idea on, I'll just discourage you that much more. So I prefer.